Hello, everyone. Thank you for the opportunity given by the organizer to present my work as a video presentation. My name is Noor, and I am PhD student at Van Yuzonjoyil University. Today, I will present study on the effect of a humic acid dose application on physiological and biochemical properties of soybean grown under salt stress conditions. Soybean, also called soja bean or soya bean, annual legume of Fabaceae family, and it is an edible seed. Soybean is one of the most important crop in the world, and its growth for oil and protein. A present world production is about 353.5 million tons of bean over 127 million hectare. The crop is grown under warm conditions in the tropic, subtropic, and temperate climate. Soybean is relatively resistant to low and very high temperature, but growth rates decrease above 35 degree and below 18 degree. Salt stress is the accumulation of excessive salt contents in the soil which eventually results in the inhibition of crop growth and leads to crop death. Humic acid is a group of molecules that bind to and help plant roots to receive water and nutrients. High humic acid level can dramatically increase yield. The objective of this study were to investigate the integrate effect of humic acid fertilizer on soybean growth and nutrient uptake. Also, to understand the mechanism underlying soybean salt tolerance, to establish the effectiveness of preparations made on the base of humic acid on the yield of a crop in case of different methods and amounts uses. Finally, to study plant growth parameters and physiological and biochemical change in soybean seedling under salt stress. Material and method. The experiment was carried out in 48 plastic pots with 500 cubic centimeter volume for replication in factorial order according to the completely randomization design. Four different humic acid doses 0, 500, 1000, 2000 parts per million, and three different NaCl salt doses 0, 125, 250 millimole. Three seeds were planted in each pot, and after germination, only one healthy plant was left. Methods: 300 mg per kilogram nitrogen, 150 mg per kilogram phosphorus, and 200 mg per kilogram potassium were applied to each pot as basic filterization. About 1 month after sowing, and when the plants reach a certain growth stage, salt stress application started. Humic acid doses were mixed into the soil before planting. Application was made by adding the solution prepared with a different salt doses as irrigation water to the nutrient solution. The experiment was ended about 7 to 8 weeks after sowing, when physiological problem occurred in the plants and the plants were harvested for necessary analysis. The growth parameters that were measured are root length, plant height, root fresh weight, plant fresh weight, root dry weight, plant dry weight. The physiological and biochemical parameters of the plants were relative water content in the leaf tissue, determination of lipid peroxidation levels, determination of ion leakage in leaf tissue, membranes endurance index in leaf tissue, leaf area chlorophyll content. The, the results of the experiment showed that Humic acid had significant effect on root length. The highest root length was when 1000 ppm humic acid applied. Humic acid did not have any significant effect on plant height. Also, no change was observed in root fresh weight with application of humic acid. The highest value of plant fresh weight was when 500 and 1000 ppm humic acid applied. The highest rooted dry weight value was when 2000 ppm humic acid applied. The highest value of the parameter was when 500 ppm humic acid applied. Both control and 1000 ppm humic acid had the same effect on MDA. The highest ion linkage value was obtained when 1000 ppm humic acid was applied. The effect of a humic acid application was non-significant of the parameter. All humic acid doses had the same significant effect on leaf surface area. Both control and 500 ppm humic acid had the same effect on chlorophyll content. We can say that root fresh and dry weight, plant fresh and dry weight, stem length, and MDA were statistically effect with salt applications. Root and stem length, leaf area, and chlorophyll content were statistically effect with the application of different humic acid doses. The effect of salt and humic acid doses applied was not found statistically significant on relative water content, membrane resistance index, and ion leakage properties in leaf tissues. The application of a humic acid superior in terms of minimizing the stress factors on plants that are adversely affected by salt stress conditions. The end, more positive results can be obtained on the physical and biochemical properties of the plant by applying humic acid applications before the stress effects are seen in the plant. Thank you for your attention.